Thank you so much for joining me on Wilder Future. This is really exciting. It's when I saw what you guys were doing, it's like science fiction. It's
Yeah,
really it's amazing. And so, just for the audience, maybe you could just explain a little bit about what you guys do and why you do it.
fantastic. Well, thank you very much for having me. And I think, just to pick up that point, we've just erased fiction. So this is just science now. So we are deep. Deep is the aquatic counterpart to a lot of the endeavors that we're seeing the private sector providing for the commercial space industry and how they face NASA, for example. So what we're trying to do is our mission is to make humans aquatic. We want to bring humans back to the sea. And in doing so, we want to make sure that we give humans the ability to go, be on the seabed, stay down there for extended periods of time, be productive. We're trying to maximize that productivity per hour depth and have it be applicable across a whole host of different sectors. It can go from things across science to different areas within defense, salvage, you name it. So again, it's make sure that we could go down there safely, use that area as intelligently as possible.
Looking at some of the architecture of how you're doing it, I was really impressed with your 3D modularity and the inherent structural stability of, I think it was mild steel in this case.
Yes, that's correct.
A huge question I have is how do you keep the ocean from just eating the outside of that piece?
We had teams of engineers. We worked very closely with an independent classing society. So just think of the same group that might go through and test your cruise ship and say, this was built in an appropriate way, it used the right materials, and it has gone through the right testing. Then you could put people on it. We're doing the same with our habitats, right? So again, this is something where we're going to have other individuals go in these habitats. We want someone else marking our homework. Again, we're only going to 200 meters, so there's still a lot of pressure, but it's not as much pressure as you might see from a full ocean depth sub. So if you have the limiting factor from our friends over at Triton, which down in Florida, Patrick Leahy, he's Canadian as well, that has a whole different kind of set of challenges. We do have those challenges, but that shape that you see is designed to kind of have that pressure vessel rating. Now, the mild steel, we have an Inconel cladding. The useful life of our habitats is around 25 to 30 years. Now, how do we kind of keep it going, right? So again, it's using those different alloys. So again, the mild steel and the Inconel cladding, which helps with a lot of the anti-fouling, a lot of the corrosiveness that might emerge from being in that environment, the ocean, which is quite dynamic. Some might say extreme, but it's also regular maintenance, regular cleaning, just like you would have any other large capital asset, whether it's a train, whether it's a plane or a truck. You need to keep it clean. You need to keep it maintained. And if you look at what these habitats are doing, this is novel. We didn't invent them. Jacques Cousteau made them cool back in the 60s and 70s. What we're trying to do is have them be large, right? So again, historical ones tended to be small. So Boeing 777, if you were to cut that 1/3, same diameter, roughly 6 meters, roughly 20 meters in length. Reconfigurable on the inside, it's modular. So those large viewports, there you're able to connect additional spans so you can create this community. We've had quite a lot of interest from several sovereign nations about being able to support or help them in those efforts to create communities on the seabed. What we're doing, and I think the key word here is just injecting optionality across the board. How can we make this very useful and valuable across its useful life, right? Something where it's redeployable, right? So again, it doesn't have to stay in a particular site of opportunity. It's deployed in depths of up to 200 meters, not just 200, up to 200 meters. That gives you coverage across most of the continental shelf around the world. Now, our founder and I have this debate all the time. He likes to represent that as you take Canada, Russia, and India, and you stitch them together. That's the same size as the continental shelf. I like to use it where if you were to take the surface area of the moon and then stitch together all the continental shelf, it's roughly the same size. We have an alien planet.
That makes sense. That totally makes sense. Now, okay, I've got so many questions. It's hard to know where to start. But one of them is interfacing with the actual ocean. If you want people to be able to go and deploy into a submarine and start exploring the region that they're in, tell me about some of the design considerations to, double locks or whatever you do to interface with the actual environment under there.
No, absolutely. I mean, this is something that's been threaded through with the structural engineering that you would have heard me just describing from the marine architects, naval engineers, we call human factors. And again, this is stealing from a lot of the work that's been going on up in space. How do people use particular areas of a structure when they're in these types of environments? And that can go anywhere from the size of a shower all the way to where do you put your equipment on, how do you enter the water, how do you get back into the structure, and so forth. And it's just routine testing. It's taking people from the 5th percentile up to the 95th percentile of height and size, right? And seeing how they are reacting in that type of environment. Now, you bring up subs. Now, the ocean, despite what you might see on a map when you open up Google Maps, is not two-dimensional. It's three-dimensional, right? And it's quite deep. So the average medium depth of the ocean is about 4 kilometers. That's pretty deep. And you're going to see there are certain technologies that are better suited, again, certainly when you compare them to the risk of being in that environment, to those particular areas. If you're going to go down to, say, 1,000 meters and beyond, certainly go further down below that, you're not going to have humans out diving. But that 0 to 200 meter zone, that's the sweet spot. That's where humans, it gets more challenging as you go deeper, to be sure, right? So this isn't kind of your PADI holiday diving that you're going through. But this is something where we need to kind of think about, right, how do we go and design the dive center, for example, that allows a dive commander to be at mission control effectively and sat there watching the divers, having all the readings, all the measurements, watching how that dive is going so that they're safe, to have a lift mechanism. So having an elevator effectively that's in the moon pool that lowers the divers down and picks them up, right? They're going to be tired. Their equipment's heavy. So thinking about a lot of those kind of dynamics about the experience and the safety of those divers has been paramount. So it's not just designing the habitat per se, it's the entire system design. And that system is inclusive of how those individuals are going to be operating. So again, we're thinking about preparation of getting your stuff on, going out, doing your package of work, and coming back, and how we can make that as streamlined and safe as possible.
Yeah, that makes sense to me. I mean, you want to make it human-centric. Otherwise, you've got these horrible death pods in the ocean. You know what I mean?
Yeah, I mean, we want, my biggest thing of success, right, was two things, which is kind of topical now, is where, you know, for me in 5 to 10 years' time, what's successful at deep? Well, there are other habitats being put out in the water, not just ours. But when someone goes down, right, they go down, they do their work, and then when they leave, they say, man, I can't wait to get back in there. Not saying, oh, that was fun, I don't really need to do that again. No. We want repeat customers. We want someone to come down and say, that was such a massive productivity boost for my research. What I was able to discover, what I'm going to be able to publish, and how that's going to benefit the broader planet is something that's what we want. And if we are able to achieve that user experience to be something where someone leaves like, that's cool and I can't wait to go back, that's a successful point for me. So you're absolutely right.
Now, when I think about some of the challenges with diving in general, with, you only have so long with an oxygen tank, and you head down, you want to get fairly deep, you're 200 meters. This is a game changer in terms of extended research at a human scale where people can still dive, but they're deep enough that they're really able to explore. Tell me more about some of the exciting things that could come from these structures.
Tyler, people are going to think that I had you plant that question. But it is the unique USP for what we're trying to do. And I think it's best explained through an example, right? So if you have, we call bounce diving. So you go on your boat, you've got a package of work, let's say it's at 100 meters, and you go and dive down. You're going to take 10 to 15, 20 minutes to get down. You're going to have 10 to 15 minutes of bottom time, and then you're going to have hours of decompression, right? So think about that bottom time that you have. It's a dynamic system. So if you're dusting stuff off, do a bit of work, it gets all covered back. You have to have the cycles of people coming through. Now, few things to unpackage here. A lot of people can do the math. If you've got 50 hours worth of work to do and you just go through that process I've described, it's going to take you a long time to do it. And that's assuming that the ocean cooperates and you can dive each day after that. It doesn't, right? So what you find is that something where in simple maths, you might think it's going to take you months, but it might take you over a year if you can't dive every single day. Second, The riskiest parts, speaking to a lot of our kind of leading divers that work for us at deep, the riskiest part of a dive is not necessarily going down, not necessarily doing the work. It's on the way up. And again, when you're seeing all those little nitrogen bubbles in your muscles and you want to prevent them from ripping out of your body, when you shake a soda bottle and just open it very fast, you want to open it very slow. That's the riskiest part. So again, go back to that point where you've only got a boat and you're going to be doing that for however many times. You're going down and decompressing each day. So now I've been told you could be a perfect physical specimen. Your equipment could be absolutely ideal and perfect. But if your body, your system is just off one day, you might be getting a little sense of a cold up your, that can cause an adverse reaction and you get the bends. With our system, right? You go down once and you come up once, right? Rather than diving for minutes, you're diving for hours, right? So you wake up, you go out, you dive for hours, you do your work, and it doesn't just stop there. You come back in, and within these habitats, you've got your dry lab, you've got your wet lab. It has connectivity via Starlink, so you can work and collaborate with your colleagues back in the bricks and mortar classrooms. What we've done is we've taken that scientific chain and consolidated it into a single subsea campus. What we have done is allow people to buy time. You can get more work done in a shorter period of time. And this isn't just me saying it. We've had several individuals who their life's work is going and doing work at 100 meters, 150 meters, and nearly brought them to tears when they recognized they could do 7 years worth of work in 30 days. And just think if you were to have that force multiplier of that discovery occurring across the ocean, I think some pretty exciting and wonderful things can emerge from that.
I can't imagine that not happening. I mean, literally, this is a game changer because, when you talked about the multiplier, it's kind of absurd. You're talking about doing years of work in days or weeks, literally.
Yes.
That's insane. I mean, and not just that. You're talking about doing a type and quality of work that would literally be impossible. I mean, when you look at, tracking an animal or some sort of strange thing or a process, I mean, there's some weird processes happening down there that we don't understand.
100%. And that's the permanent presence of being down there, right? So we have the fortune of our director of scientific research, Dr. Dawn Carnegas. She participated in the NEMO expeditions, which was a NASA program where they took astronauts or people who were trying to become astronaut candidates, and they put them in a subsea habitat for 2 weeks off of the coast of Florida. And they'd be sitting there, and they'd have their coffee in the morning, looking at a viewport, and they'd just be observing some wonderfully odd behavior from local creatures or fish, and they would record them on their phone and send them, back to their colleagues who might be marine biology professors or researchers, like, "Oh, have you seen this?" And unequivocally, never seen anything like that before. Like, astonishing. And so again, just being down there, just kind of having eyeballs beneath the surface of the ocean, you start to observe things in their natural states and what we're able to learn from those kind of dynamics, and you extend that further beyond just watching fish swim around in a weird pattern. Again, it can be quite powerful. And it's one of those where it's just a thought exercise. We see this massive, fascination with space. Well, you got to go to space. You got to be multiplanetary. And I love the ambition that's from that. But if we look at things that are real and near to us now, and you're just going to say, is it more likely that we're going to find a cure or sustainable treatment for cancer in space or in the ocean? I would like to probably bet, and I'm not just talking my book here, that we find it in the ocean rather than the moon or Mars.
Yeah, I would totally agree with that. And the reason why is because there's a diversity of life and therefore a diversity of processes that could actually lead to something that we've missed. I totally agree with that.
Yep. Yeah, it's again, you're exactly right. It's the biology of these different creatures being able to survive. Not just survive, but thrive down in that environment. It shows exceptional biology, without a doubt.
There is I forget what it's called, but there's a type of, some sort of a snail, and it lives in these volcanic vents, and it creates this metallic iron in its actual shell. And so when we think about things like that, I mean, bioaccumulation or production of metallics could be an absolute game changer when you think about how difficult it is to smelt and molten steel. And these little guys are just making it on the. It's pretty wild.
It's nature's. I'd say Mother Nature is the best engineer, and that's something we need to kind of keep in mind when we're doing all this.
Yeah. Okay. So there's so many questions, so many different directions we could take this, but I'm just thinking about timelines, how long people can live down there, and social dynamics. I mean, one of the things I think a lot about is if we're going to live on Mars, the moon, or in deep sea, we're going to have to think about like what you just mentioned, which is those human factors. So yes. I guess how long are you anticipating people can live in these things? And what are some of the real difficult design considerations that go into those calculations for you?
Oh, 100%. So all good points. So in terms of timelines, I mean, the first timelines, our habitats will be in the water this year. So the first one, our expeditionary class habitat will be in the water end of this year. Sentinel, which is the flagship larger habitat, will be in the water next year. So in terms of time, so what we're looking at now for the expeditionary class habitat, meant to be a bit more tactical, redeployable in a more streamlined way, support a crew of 3 to 4 people. That's up to 7 days. Again, that's for a very specific package of work. So it definitely has a more kind of mobile element to it. Sentinel, on the other hand, is redeployable, but it's tended to be more of a semi-permanent type of installation where it might only be moved a handful of times through its useful life. That's up to 28 days. Now, the 28 days has been informed by, we've kind of crafted a lot of these regulations here in the United Kingdom. From the health and safety executive, that tends to be the guideline for individuals in saturation. That's when you're in that environment and you become equilibrated to that pressure that you're at. Now, there's a range of different numbers. If you go out to the Far East, it could be up to 90 days, right? It could be fewer, but that's kind of what we're guiding and where we're starting. Now, the problem is there's not a lot of data to support this, right? The U.S. Navy did some observations decades ago, but it was very blunt. They came through, and it was very narrow. It was, young males who felt they were invincible, and they really just kind of asked them a very blunt question: did you get the bends or not? Well, our capacity to better understand our physiology, right? We all wear wearables. We know what our heart rate variability is, continuous glucose monitoring, so we can understand at a more minute level the impact from being in saturation, right? So from that, then we can have a broader set of individuals that are going down there, right? Not just trained Navy divers, and try to understand, okay, well, what is the right time to be going down there? So at the moment, 7 to 28, that's our baseline. But as we get more data, we can help inform better policy and better guidelines to make sure that people are able to go down there and do so safely and do so where it helps to prolong continued use, through their diveable lives.
So this is, I think, a critical piece of the puzzle. I mean, if we're looking at literally setting up the bases on the moon or Mars, or even just, continuing with the ISS, I mean, we have to look at extended stay. We have to.
100% no. And I think you're definitely attaching on to that key point of the Nemo expeditions. It's the crew dynamics. And we've had quite a lot of interest. We've had quite a lot of discussions with the private sector commercial space industry now, where they're looking to bring, humans, beyond low Earth orbit, bring them to Mars, bring them to the moon. It's making sure that when you do put them in a steel tube and they can't just open the door and leave, and, when they have problems and the crew dynamics, to make sure that they have the mental fortitude and capacity to go and survive that trip. But if you're going to Mars, it's not just getting out there. You're going to be isolated there for at least 1 year to 2 years until the orbital kind of lineup makes it feasible for you to come back to Earth. So they see a lot of value in going down this path. Now, they've got different strategies where they might whack you out in the forest and say, all right, go find your way back and work together as a team. But you don't really feel like your life is in danger. You don't really feel like you're putting your crew's lives in danger. But when you're in a saturated environment, you can't just go up. You can't just open the door. right? Because everyone is in that same situation because you risk getting the bends or something worse, right? So you have to think critically. You have to think under pressure and how you're able to solve that. And if before you go and spend all that money to send someone to the moon, probably should use this as an opportunity to kind of figure that out. Now, you don't just take someone, put them down to 200 meters, for example. We have a sequence of different training frameworks that we operate. So we have that will sit on the surface. It's our habitat simulator. It's a 1-for-1 size Sentinel. You can look on our website. It's there at our campus in the United Kingdom, and it rests on 2 pontoons, and the moon pools are submerged. And you're able to go, and for that first pass for a week, lock a crew in there, run them through the standard operating procedures, emergency operating procedures. They put all the gear on, dive through the moon pool into our quarry, and come back. From that, you're able to observe. You can see the mental impact on being locked in there, the crew dynamics, their capacity to go and iterate in terms of improvisation if they need to come solve a challenge and an issue. And then from there, you graduate. Then you go and you can go into a shallower deployment and then the deeper one before you get up to space. So I like to say, you're going to get to space through the ocean. And we see ourselves as a critical component within that training program.
Oh, absolutely. That makes so much sense to me. The ultimate would be cold water under ice. Yes. And extended. Because now you're into a situation which is pretty serious. There is no easy escape. There has to be a lot of consideration for exit and for getting in. And one of the pieces that I wanted to kind of throw your way is, have you guys looked at or thought about the idea of pleasure? Things like saunas and cold plunges integrated with the experience.
I mean, it's a good question. So the first part is so the Sentinel can't go into Arctic regions yet. So that's something maybe we kind of down the line as we kind of look to innovate around that front. But in terms of the experience, the wellness trend, right? That is certainly an area to tap into, right? So you kind of have that component where you're describing the thermal journey. You kind of go into warm water to cold water, for example. But there is, without a doubt, a very meditative element to diving, which has, I think, a very large benefit to mental health, right? And I can share a personal kind of story on that. My prior life, not an engineer, not a scientist, I'm an ex-hedge fund manager, right? And so kind of going through that period where you have that constant validation of you're doing well, you're not doing well. It's very stressful, lots of information and noise coming at you. But one of the few times where I felt at peace was when I was diving. First off, I mean, obviously, all of your phones and things like that are left on the boats. Okay, tick, positive one. Second, all you hear is just the motions of the ocean, right? You hear all of the critters kind of, chomping on the coral or making whatever sound they need to make. So again, there's a very soothing white noise aspect that comes to that. But the one thing that's critical where you really see this integration with diving is your breath control. As we all know, before you go on stage and speak, and you probably very well know when you do these, you have to really get your breath under control, and that calms you down and then really soothes your kind of thinking and really streamlines it. If I want to maximize my time down there, I need to be really smart with how I breathe, right? Because I'm going to conserve my gas. And it's also using your lungs, just think of them as 2 balloons, is a great way to control your buoyancy. So how you are floating within the water if you want to be idle in front of a beautiful fish or piece of coral. So again, you really have to center yourself, control your breathing. So when you think about it from that perspective, where you can go down and have that unique experience, you can go out and have that, I think, very much a wellness-oriented experience, then yeah, I think there's certainly something to kind of come from that market in terms of that adventure tourism, I guess, is one way to think about it. So, it wasn't the way we set out to go and do this, but as we start to have more of our habitats around the world in terms of different nations that are looking to have them, this is certainly a market that I think is going to be opened and will certainly expand over the years.
Well, I think if you look at Virgin Galactic, certainly the tourism element is a huge potential market. When you think about just the human level of wellness, it's like, money doesn't make you happy, but not having a hot shower probably makes you unhappy over a long period. You know?
Yes. Yeah. No. 100%. 100%.
Yeah. Now, okay, some of the questions I had as well about this Chinese project that I came across, they're looking at some pretty wild parameters. I mean, 2,000 feet underwater, extended periods, like long missions. Tell me about some of your thoughts around some of these and maybe other projects that are going on right now. I think those are longer term than what you're doing, but yeah.
No. I mean, for me, it's one of those that it makes me happy, right? Because it's a validating move, right? To see a nation like China and seeing other groups that are out there that see the value, that see the opportunity with bringing humans into that type of environment in a safe way to allow that kind of more fluid access, I think it's a validating mark. So, and they're really being the first mover here, right? So we're doing our bit, but we're private sector. This is a nation coming through saying, we are going to go down there. We are going to put our people on that continental shelf. And there was an article out of The Guardian where you're seeing more and more of this across the board. So more nations, and we've had conversations with a similar kind of idea and hope. They want to put people on the seabed, right? It's in effect a quasi flag planting, right? And it's the Hawthorne effect. When you know people are down there and they might be watching, not robots, then you're going to alter behavior in terms of how people operate around there. So for me, it's a mark. They're leading at the moment, right? So if you kind of look at, is there any other nation talking about this? No. It's China. China's the one that's kind of has that first move. It's the last blind spot. We can see into deep space. We can see near space. We can see our airspace. We can see land. We can see the surface. We don't have a good grasp of what's going on beneath the surface of the ocean. And I think this is that first move. What we have now unfolding, and we are very much in the foothills. We had the outer space race in the 60s and 70s. We now have the interspace race. So we saw Russia went first, and then the U.S. came back. China has just gone first in the interspace race. And now we're waiting to see if the U.S., for example, is going to come back in and enter that race. I suspect they are. I suspect that they also see the need and the requirement to have control or at least proficiency in that domain. And I would be very, very surprised if that type of conversation is not taking place in the White House, if that conversation is not taking place within the Department of Defense.
Yeah, I totally agree. I mean, how could it not be? Maybe tell us about what's the depth really that humans can swim around with gear without dying, pressure-wise, everything else, and below.
So I think you're not going to get anywhere really beyond 300 meters, 400 meters, right? So if you kind of watch Megalodon 2 and you have Jason Statham freediving at, thousands of meters, that ain't going to happen. So, again, I'm not the technical diver here, but I've had similar questions that put to the team. I think if you look at the record scuba dive, it's a couple hundred meters. And so when you start thinking about being down there, you might not have people, diving in scuba gear, rebreathers and things like that. But what you're able to use are things called atmospheric diving suits. And you have a wonderful company in your great country of Canada called Nuco out in Vancouver that is a pioneer in atmospheric diving suits. Just think of it like a personal submarine. So it looks like an Iron Man suit, but allows you to go and dive down to those depths. And you'll have manipulators and you have articulating arms and so forth that allow you to go and work in that environment in a one atmosphere suit, which means one atmosphere means it's the same pressure as having one atmosphere on us that you and I are experiencing now, the same gas mix, but it allows you to be down there and kind of operate in an open way as compared to if you were in a larger submersible. So what it means is that it's probably just going to be different tools, different techniques, but you won't see people scuba diving outside of those habitats. I'd be very surprised, as would most, if that were the case.
That totally makes sense to me. So when we look at a future of actually understanding the continental shelf, then we are going to have to be going past and way past where people can exist, but that's fine. You can't exist in space. So what kind of interests do you have in the next phase of of super deep submersible habitats, and what do you see some of the opportunities being?
Yeah, I mean, for us, we're just focused right now on this 0 to 200 meter kind of zone. We see that as the big blind spot, big opportunity zone, because it's too shallow for submersibles to really go down. Anything beyond 20 meters, you start to greatly reduce the amount of number of individuals that can go down in that area. ROVs not really going to kind of use those. So we're trying to really address that need there. Going down in the future, I mean, again, something we would never steer away from. Again, we can explore whether we pursue it or not. That's a whole different set of questions. But we felt the biggest impact and driver we could provide would be really nailing this 0 to 200 meter zone. So that for now, that's our focus. But what we also would hope to do is to set an example about intelligent symbiosis with the ocean, between humans and the ocean. Can we go down there, do so intelligently? You know, we don't want to kind of saying, well, humans always ruin everything they go to. I disagree with that. You know, certain actions do, but there's a very intelligent kind of halfway house where it's beneficial for humans to be there, and it's beneficial for the environment as well. And we want to make sure that we're able to lead by example on that front. And once we're able to do that, hopefully that kind of standard and culture propagates out to the broader ocean exploration environments and industry.
What kind of benefits do you think could be achieved?
So with our habitats. So I mean, I think, you know, there's a lot of work that could be going on from an environmental perspective, right? So you're looking at, so one of the things that kind of pops up is trying to understand these very kind of sensitive ecosystems like the corals, how they're reacting to global warming sea temperatures and so forth. And we're seeing pockets of coral that are dying off, bleaching and so forth. But once you start to go down to deeper corals, you see corals that are adaptive, ones where we can learn the biology of those corals and how they might be able to allow us better understand how we can remediate, rehabilitate these corals and make sure we can bring those up, for example, and start to repopulate a lot of these kind of, you know, very important organisms and so forth that are central to the ocean. The other is just sheer discovery. When human divers go down in a scientific mission, particularly going beyond the 20-meter zone, they find on average, you know, nearly a dozen new species. So again, you see the work that's being done by Ocean Census and the Necton group, right, where they're just looking to create that zoological taxonomy of all these creatures in the ocean. You know, on their estimates, we've only discovered about 30% of what we think is in there. So again, it's better understanding our own planet, better understanding this very dynamic ecosystem and how it influences so many of the systems that we take for granted up here on land, right? That little area, that kind of millimeters, the air to sea interaction explains a large chunk of the type of weather patterns that we experience, right? It's that exchange between the ocean being a large carbon and heat sink, and then how that propagates back up and influences in a very kind of dynamic way. So again, knowledge gain without a doubt. Think about it as well. Going back to geopolitical concerns, critical undersea infrastructure. The large majority, there is no cloud. There is just ocean. Most of our internet traffic goes through subsea cables, straight up. If you want to think about where vulnerability sits at any kind of escalation, it's there, right? Energy, a lot of it tends to get transported, about 40 to 50% of it gets transported through subsea pipelines. Again, critical undersea infrastructure. So that's another element where just from routine maintenance, observation, back to our kind of Hawthorne effect example that we're describing before, you know, that's going to be critical to kind of have that operation down there. There's more and more that we can kind of go through, but those are the ones that I think certainly from a sense of immediacy have been most relevant to the groups that have been engaging us so far to have use of our habitats.
No, absolutely. This is kind of a side note, but I'm curious as to how you move these things. Are these, do they have their own ability to kind of propel even a small amount? Are they?
So for a version 1, no propulsion. But what these would be able to do is, so like Sensible, so the Sensible could be taken apart. So it has 5 pieces, 2 end caps and 3 ones in the middle. And you can take those apart for ease of transport. If you want to kind of move them on a road, the 6 meters was chosen intentionally because it'll fit most large roads, for example. So you'd effectively take them out on a barge, right? And then you would have them lifted and floated, so they'd be positively buoyant. And you'd have the anchoring system already pre-installed in the seabed. So this would take, a few months of preparation, environmental impact study, for example. You'd have those anchors in, and then you would have the structure as the ballast would be kind of flattened and bring it down as it goes from positively buoyant to negatively buoyant, and it would be guided down on cables, and then it would lock in. It's more complicated than this, but for my small brain, it's just like clicking your heel into a ski boot. That's effectively a similar type of mechanism that we'd be looking to employ.
Yeah, that's cool. That absolutely makes sense. And I guess because it has to be full of air and everything else, it has to be kind of buoyant anyway, so it's maybe really smart to anchor it down to the ground.
Yeah, exactly. So you'd have just the kind of the displacement of the water and the air on the inside. It's a large space. It's like 470 meters cubed. So it's big on the inside for the Sentinel. So yeah, so it's a big space. So bringing that down, you're right. But you'd have to kind of, they're within the ballast system. You'd have to kind of, fill it up with water, for example, bring on the outside, so not on the inside, and bring that down. But having that mechanism, because it's not like it's your swimming pool either down there. There's a current, right? So you have to think about the current that you have to kind of, and it might be changing at different levels. So again, to create that stability, particularly if you've kind of got certain kind of currents picking up for a particular period, say the storm's going above on the surface, we need to make sure that the crew's safe. Again, first and foremost, rule number one, everyone comes back safe. Rule number two, see rule number one, right? That is without a doubt what we care about.
Yeah, absolutely. And especially there was that sub maybe a year ago or something that collapsed. I mean, what a horrible story.
Yeah, it was. I mean, again, it was without a doubt a tragedy, but looking at ways that went through its whole design process, ours aren't going down to thousands and thousands of meters, different pressure challenges, but we're having ours classed, right? So we are having the critical components classed. Unfortunately, that group did not. It is an important thing to make sure that you've got good peer review, independent review of your structures that are being put in place.
Yeah, you want as many eyes on something like this as possible just to make sure that there are no little missed things.
There's two parts, right? It's not just the hard engineering. So we're getting that validation on the stuff you can tap your knuckles on. There's a human engineering element as well, right? So you want to make sure that the crew and the operators are going to have the right amount of training, right? So it's not just kind of going and doing a PADI or a GUE or an international training kind of coursework. As having something that's specific to habitat diving as well. Again, what's unique about that, what to expect, how to do so safely. So again, it's having that training build up to that point. The humans are just as important, if not more important, to safety. You look at a lot of these structures when they kind of have that independent validation and verification, they're pretty sound. It tends to be the humans that get in the way. So making sure people are properly trained to go down there and safely and productively use that stuff, that's also a very critical stream with what we're doing.
Yeah, I could absolutely see that. Now, what about kind of emergency procedures, like if there's a fire or if a blue whale smashes a piece?
So I'm sure the team has thought about the whole blue whale stuff. I haven't asked that question, so I have an answer for you, unfortunately. But on things like, fire, for example, there are 4 ways in and out of the habitat. So you're going to have your primary moon pool and emergency moon pool. You're going to have your primary dry transfer, right? So again, it's just a hatch on the top of it where you can have a sub go and mate and do the extraction. Again, you pressurize the surface and come down. And then there's a multi-purpose module that will be on the other side. And think of it as like a hyperbaric lifeboat where you can go and the crew, I'm not going to say they're going to have a spacious suite, but they'll be in there and they'll have life support for 5 days. They can go in there and depart. You can also have the multi-purpose module, another one, exterior. So if you're able to get out, like you can go out through the moon pool, emergency moon pool, and go into the multi-purpose module on the exterior. That's another safety element. So again, It comes through with having the materials, the procedures, the equipment down there, a well-trained team that's able to react and operate in an effective way in that type of situation. So it's giving them redundancies, tools, and training. It's the same thing for injured individuals, right? And this comes down to a lot of that kind of human factors design. So say you have a diver that gets injured, how are you able to get them into the lift, but then have the tracks on the top if you need to kind of bring them through and then get them up to the dry transfer. So again, thinking about that entire system design has been something that's why it takes a long time to do this. It's why it takes a lot of money to do these things. But yeah, so that's my kind of non safety expert explanation.
Another question that's like maybe related, maybe not, but I always find with any project there are disproportionately hard problems in one, or if you're rock climbing, there's like a crux in every climb.
Yep.
Can you think of any kind of specific challenge that was difficult?
I mean, so one of them was in terms of, there's a few, and there's different ways to think about this. So off the top of my head, the first was how we're able to build these. So we would not be able to build our habitats the way we are, which really unlocks a lot of the efficiencies in terms of the economics of it, the distribution of capabilities, optionality. We wouldn't be able to do this with conventional means. It's our 3D printing capability, so our advanced manufacturing arm, that really unlocks a lot of that. So that was our first big challenge. We kind of come up into this and say, all right, how are we able to kind of deliver something that's operationally feasible, but economically not going to absolutely just bankrupt us? And what really kind of, through that curiosity, and that's the beauty of this group, is we are curious individuals and we like to solve these types of problems. And that's why we went down that path of advanced manufacturing. So that's one side. I mean, really the next one is how do we create something of that size that allows people to stay out for extended periods of time, but provides the redeployability, the modularity. So again, that design tenet of optionality across the board, that took a long time to kind of make sure we find all these different trade-offs without sacrificing the safety component, to be sure. So again, on that side, again, pressure is a challenge. 200 meters, it's not 4 kilometers, not 4,000 meters, but it's still a lot. And it's something that's very challenging for humans. So how we're able to kind of go and design that and satisfy that component. The other kind of challenge is looking at all the topside infrastructure. How can we take that and bring it down into the system and create more of an autonomous system? So I'm sure you have Celeste, if they work in the oil and gas industry, they have diving bell systems. So a hyperbaric system that sits on a large boat, very large boat, which costs a lot of money. And then the bell, just think of it like a bell, and it brings you down. You do your work, you go back up, and you swap crews. You go in the living chamber, and then the next crew goes down. It's a large footprint. So the big challenge was how can we go create that habitat and take as much of that topside infrastructure and locate it inside the habitat. Now, that's a big design challenge. It's a big engineering challenge. But by doing so, that starts to unlock a lot of the optionality I was talking about before. That gives you that modularity. It gives you greater ease of the redeployability and all of that. So again, that was a big challenge. But again, for now, those are the challenges we've overcome. As we start moving into kind of the operations and when we want to do Sensible 2.0 and 3.0, it will be based upon probably a lot of the feedback. So the feedback we get from the end users, I wish we would have had this, that didn't work too well, or we start to see the operations of how we can improve that whole process, then we'll have new problems. But the thing is, we've got the right team for new problems. They weren't just here to do one thing. We recognize that this is just going to be a never-ending series of challenges, and we've got the right team to come together, think about these, iterate around these, and do so in an effective and safe way.
Yeah, it sounds like it. I mean, just looking at a lot of the solutions, they're novel and they're intelligent. I mean, looking at casting something the size that you're making, it doesn't really make sense. I think your additive manufacturing really makes a lot of sense. And then another question, how much infrastructure do you have above water? I mean, if you've got Starlink, I'm assuming you got to have some kind of boat pointing at the sky.
Yeah. So to start, like the first iteration, when we put the first one in, it won't be the size of the boats I was talking about, but we'll have a footprint just to go through in case we want to work on it. You pull it up and kind of tighten a few bolts, for example. So we'll have a little bit more of a topside infrastructure, but as we move forward to the next phase, we're going to see the maturity of those systems bring it all down. So you'll always have a comms buoy, because that's one of the big challenges. Being subsea is high quality comms over distance is very challenging. So relying on a communications buoy will be there, and there will be other redundancies, whether it's kind of backup power with batteries, or a renewable energy buoy, for example, if you want to kind of capture some wind, tidal, or solar energy, for example. And you'll always have a boat. Again, it might not be boat necessarily that has to stay on top of it all the time, but you need to kind of, depending upon how far you are from shore, will influence what you have on the top side there. If you are very, very far offshore, you probably do want to have some boat there. It might make sense to do that. But again, that's something that's highly dependent upon, what the situation is and where the location of the deployment is as well.
Now, personally, that sounds like a really tough design challenge, because you're tethered from the bottom, and now you have a connection to the top, but the top is an undulating, wave-filled thing. So talk to me about some of those challenges. You can't move too far from your bottom tether. This could move far, breaking lines. I mean, it seems like a bit of a challenge, like a huge challenge, actually.
Yeah. No. So again, this is something that the kind of engineers have had to grapple with and think about as well. And it might be a dynamic positioning that's on the buoy as well that allows it to kind of auto-correct itself if it starts to go too far. You don't want to leave too much give as well. You don't want too tight of a line. So trying to find that balance. Again, it's also where it's viewing those as almost as a redundancy. For example, where you want to make sure that it doesn't cause anything to move with the habitat. It won't, but if it has to break away, it breaks away. But then that kind of sends a signal to safety that they need to come.
Power-wise, what are you guys thinking to keep these things powered?
Yeah, I think just to start, it's going to be, think of, battery grids that will be around there. So you've seen, subsea batteries, the tech has improved quite a bit over the years and continue to see it improve moving forward. But we're exploring, again, as ever, like anyone else, different ways to kind of help power and drive these habitats. And it starts with just being as efficient as possible with the habitat, so you can get a lot of cost savings through that way. And there are a lot of interesting and emerging technologies out there about how you're able to kind of harness tidal energy, again, renewable energy as well. So we don't want to be burning. We're not going to be burning diesel, for example, to run these. It kind of runs contra to what we're trying to do. And so again, it's one of those where it's interchangeable. So as we always do, humans, we're very good at innovation and moving forward and progressing. As we get new technologies that increase the energy density of these particular batteries or other means, then we're able to kind of go and adapt and slot that in without a major, if any, overhaul to our engineering system.
Now, in terms of cleaning air, water, food, I don't know, any thoughts on that piece?
Yeah. So again, nothing novel per se to start on the clean air. So it's using scrubbing, which is very similar to what you're going to have up the International Space Station, very similar to what you have in submarines. So it's a particular material where you cycle the air through, it extracts the carbon dioxide, inject a little bit of the air mix that you're breathing down there, depending upon your depth, and then that kind of keeps you going for your month or more at a time. We are also have a research and innovation group. They're working on a thing called a bioreactor. It's just growing algae in a tank. And it just helps to kind of, again, biomimetic. You're using the natural systems of the planet to harness that power and utilize it for our means. And you can also eat it if you want, if you run out of food, which then leads us on to, all right, well, how do you eat? Now, one of the big challenges when you're down there is your taste buds don't work as well. It's the pressure of what it does to your olfactory system, which is a big driver of your taste. So what you find is a lot of guys and gals that go into these diving bells, oil and gas, they got holsters of Tabasco, Frank's Red Hot, sriracha, because they just throw it over everything so they can get some taste. So it's how can we design nutritional program where maybe it gives a bit of flavor, because we all know if you eat bland stuff a lot, you're going to go crazy. If you don't sleep, you're going to go crazy. So thinking about that, we need to take that into account. You metabolize different nutrients in certain ways. So sous vide, just again, same thing like you might have up in space, meals. That allows for kind of efficient usage of space down there when you're storing this food. Make sure that you're not going to, run out because of fouling, for example. And so it's just as simple, it's tried and true, right? If it ain't broke, don't fix it. And so let's go and do it. And then we can think about, again, feedback. What are ways to improve upon that? And, as you cycle crew out, you get new supplies that come down.
In terms of sleeping, you mentioned if you don't sleep well, you're not going to be in a good place. So tell me a bit about...
Human factors comes into this. And again, great with the story. Come back to Dr. Dawn Carnegie when she's on Nemo. So they were in saturated environment, and what it does to your sinuses and so forth, and kind of the pressure, is you tend to snore a lot. And they were in bunk beds. No one really slept for their 2-week period, to the point where she had to listen to heavy metal to create a noise barrier from all the snoring so she could sleep, which is astonishing. Within our habitats in Sentinel, you have your own accommodation, right? It's not a 4-season suite, but it is a soundproofed personal area with your bed that allows you to kind of go and FaceTime with loved ones, FaceTime with colleagues, read a book, or just sleep and get good sleep. So again, it's an extremely important thing. Kids, I now know sleep is an extremely important thing, and I value it immensely. And I know my productivity falls when I don't get good quality sleep. And when you're down there in that type of environment, you've got a very specific package of work, and it does require you to keep safety front and center. Sleep's important. So we made sure that was kind of inbuilt into that design. Thinking about the people going down there, we want people, again, to leave and then say, I can't wait to go back down. Not because it was ultra luxurious, but because they were able to do great work and they didn't feel horrible when they left.
Yeah, it sounds like taking away the friction of what makes a horrible experience. And not sleeping is literal torture.
Yes, indeed. I think they do use that when they torture people.
So what kind of dimensionality are we talking about with these little mini suites?
I'm trying to lay down maybe 2 meters by 2 meters. So again, it's gonna give you a bed that kind of goes from coverage there, a little place to keep your personal belongings and so forth. But the idea is that you're there to sleep. Most of the time, you're either out diving, or you're in the labs, or you are having some social time down in the Great Hall section of the habitat.
And tell me about the Great Hall. What does that kind of look like?
But it is the area where it has the great views. Right, you've got all these 2-meter wide acrylic viewports dotted around. So again, connects you with the outside area. That's where you'll have your meals. That's where you'll sit down and talk about whatever with your colleagues, your fellow Aquans. It could be the package of work. It could be stuff going on back in your home country. It could be your local sports team, whatever it might be. But it gives you that area of social interaction. You have the dry lab, which is up on the second deck, but it's meant to be an open-aired environment that kind of doesn't give you that sense of in a sub. It's something where it makes you feel more at peace, more connected with the surrounding environment, which again is what we're trying to do. We're trying to close that gap between humanity and the sea, and that's not just something where it's getting you wet. It's also kind of putting you that environment so you grow to appreciate it, grow to love it, and grow to protect it.
Yeah, I mean, honestly, I'm blown away by the work you guys are doing. Are there any other kind of things that you see coming down the horizon? I mean, we've got Vanguard launching very soon, Sentinel coming next year.
I mean, I think, it's really kind of always going back to what's our North Star, right? And again, it's I come back to this unreachable gap between humans and the ocean. And so we're a habitat company, straight up, right? That's what we do. We create habitats, and we do so in a way that will continue to evolve and make that more accessible to broader individuals. Another exciting kind of development that's really kind of picked up pace is our research platform called FLIP, which is a floating instrument platform. I don't know if you've seen it. It's a really, really, really awkward-looking research platform. So it's 100 meters long, and it's a platform. It used to be owned by the U.S. Navy. We rescued it last year, and it inverts. It's called a spar buoy. So it fills with water on this end, and then it inverts. And in insane sea states, it remains remarkably stable, which allows for, an abundance of different types of research, whether that's kind of looking at all the different ocean physics and chemistry, sampling for ocean plastics, a lot of acoustical work as well. There's no engines on it. So again, you don't have to kind of start to filter that out. And the stability, remember I said earlier about the importance of that few millimeters in the surface of the water? This greatly enables better sampling and research at that layer because of its stability. So it's an essential part of many groups' programs. So what we're doing here is it's a symbol. It was a legendary asset. It was going to scrap. We had the wherewithal to kind of step in and prevent that from happening. It was primarily in the Pacific Ocean. It went through the Panama Canal very briefly in the early 70s, and it made its second trip through the Panama Canal last year when we brought it out to the Mediterranean to get refit. So break it all down, give it a massive facelift, and bring it into the 21st century. And what it's doing is it's going to give us, a mobile kind of platform to go around and contribute research, to inspire, to kind of bring more people into the ocean. So, what we're looking to do, again, is bring greater degrees of eyeballs to the sea. If we can get them below the sea, even better. It'll be a transformative impact. But what we want people to understand is, the importance of the ocean for so many things we take for granted here on land. And again, it's just trying to go from, if you want to protect something, you need to understand it and you need to love it. And try to take that kind of sequence of decisions and states to heart.
Okay, Sean, another quick question.
Yes.
Too, so the physics involved with this flipping thing, I could probably just do research on, but just in brief, how does that thing work? Is it air, ballast,
Yeah, so you've got different sections. So if you think along the long part of the hull, you're going to have 5 compartments, and on the bottom 2, you fill with water. And if you think you fill this with water, this is going to start to sink, and then you're going to have weight up here and weight down there. So they're called spar buoys, SPAR. And that's the technical term. And then they turned this one into a research platform. But it's, by having it set up that way, I've kind of extended the my knowledge of physics in that sense. But yeah, I mean, there's a bunch of research on there on our website as well. You can find some good stuff.
Yeah, I'll do a deep dive there. Now, bathrooms. That's my other question. How do people go to the bathroom in these things? Tell me a little bit about all that.
Yeah, you have two bathrooms, right? So you're going to have one in the wet section, one both in the wet section, one top deck, one on the lower deck. You have a shower as well. It's more about what happens to it afterwards. And we collect that gray water and black water in bladders, and we just cycle those through and have them, brought back to shore and handled in a safe and environmentally friendly way. So again, goes through all that processing. So collect it. And again, when we're going through a lot of the permitting, that was always the top question. What are you going to do with your waste? They don't want you just whacking it out into the sea.
I mean, future developments, could you do anaerobic digestion and maybe even capture the methane, use it as fuel? I mean, obviously that's a lot of complication, but I'm just curious.
Yeah, without a doubt, I'm sure. I don't see why that couldn't be something we can explore, right? So I think any of those kind of innovations where that's a challenge that I'm sure they're going to be trying to solve up in space, and a challenge that they're going to try to solve elsewhere here in the planet. So just being part of these communities and these kind of networks and so forth, and seeing the maturity of these different ideas and how it might be adapted and suitable for what we're doing, I would never. There's never a bad idea. So always something worth exploring. What we need now is kind of really to inspire that next generation at the grassroots level. That's the most fun that I have. But it is a magical place. A lot of the world's secrets are still down there, and we will become better stewards, better partners, for the planet. And hey, come help us make humans aquatic.
Well said. Thank you so much, Sean. This is Wilder Future with Tyler Steves on 92.7 CFFF FM, broadcasting live on the facilities of Trent Radio. Have a great night.